At the moment on router 2, show IP BGP summary shows us that the router has one neighbor relationship to router 1. The local router has a BGP identifier of 17.17.17.2. Local AS number is 17. But notice there is no relationship to router 3. On router 3, show IP BGP summary shows us that BGP is not active on the router. eBGP relationships are configured typically using physical interfaces. In other words, using the local link IP address. So on router 2, we're going to point to this IP address. And on router 3, we're going to form a neighbor relationship with this IP address. The reason why is that you don't run an IGP between autonomous systems. An IGP runs within an autonomous system, hence the name IGP or Interior Gateway Protocol. BGP is an Exterior Gateway Protocol or EGP and runs between autonomous systems. Now you can use static routes to form neighbor relationships between loopbacks, but typically that's not done, especially when you've only got a single connection or single link between your autonomous systems. You're going to use the physical IP address for the neighbor relationship. So we're going to type router BGP 17 neighbor 8.1.1.2, whole bunch of options, but the one we're interested in is remote AS, and in this case it's going to be AS8. No neighbor relationship will be configured unless we configure the other side. So router BGP 8 neighbor 8.1.1.1 remote AS 17. Show IP BGP summary. We can see that the local router has a neighbor configured with this IP address in autonomous system 17. The local autonomous system is 8. The relationship is idle at the moment. Still idle. Let's see on this side. Show IP BGP summary. We can see that a neighbor relationship is active on this side, but is not established yet. So let's confirm that we've got our configuration configured right. But notice there our neighbor relationship has just come up. So that means it looks good. Show IP BGP summary. We see a bunch of information once again, that the local router identifier is this. It's using the loopback IP address as its router ID. Local AS number is 8. The BGP table version is 4 because it received 3 routes from router 2. Started with 1 and 3 routes were added. Previously, notice the version was 1. We received 3 routes, so now the version number is 4. Messages received and sent are shown here. BGP table version once again is 4. Neighbor relationship has been up for 13 seconds to this neighbor using BGP version 4. So all we did is configure a neighbor relationship on both sides. That's the config on router 2. Here's the config on router 3. We configured BGP with the neighbor relationship, and that's all we had to do. On router 3, show IP route. Notice we are learning routes through BGP. This network is being advertised through BGP to router 2, and router 2 is advertising it to router 3 using BGP. It's not being redistributed from OSPF. It's going directly into BGP using the network command and being advertised along the network to router 3 using BGP. And there's the route in the IP routing table. And if we look at the BGP table, we can see there's the route in the BGP routing table. It was learnt from autonomous system 17. Hence the autonomous system path shows 17 in the list. The next hop router is 8.1.1.1. So can we ping 17.17.17.1? At the moment the pings are failing. Let's do a debug IP ICMP on router 1 to check if the pings are actually getting to router 1. As you can see, the ping is getting to router 1, but router 1 doesn't know how to get back to router 3. In other words, router 3 knows how to get to this IP address, but router 1 doesn't know how to get back to router 3 because we haven't advertised this network into BGP. So on router 2, router BGP 17. Network 8.1.1.0. Mask, it's a /30 mask here. Once again, ideally you want to do the show IP route command first to see what your network is configured as. It's a /30 mask, so hence I've used this mask here. So show IP BGP. You can see that network has now been advertised into BGP. So on router 1, are we receiving that route through BGP? Yes, we are. Is it in the IP routing table? Yes, it is. So now, hopefully, router 3 can ping the loopback of router 1, and it can. The ping succeeds. Now, you don't have to advertise this network on both routers, but I'm going to do that anyway, because typically the ISP is not going to trust the configuration of a customer. So network 8.1.1.0, mask 255.255.252. Show IP BGP. We can see that that network is being advertised by the local router, and it's being advertised from 8.1.1.1. The local entry is preferred. So what have we done? We've configured eBGP between router 2 and router 3. And what I'll do now is configure eBGP between router 2 and router 4. So on router 2, conf t, let's move this up a bit so we can see the IP addresses. Router BGP 17, neighbor 4.1.3.2, remote AS, and in this case it's autonomous system 4. And I'll advertise that network while we're here, so 4.1.3.0 with a mask of /30. Router 4, show IP protocols. No IP protocols are currently enabled. So router BGP 4, neighbor 4.1.3.1, remote AS is 17, network 4.1.3.0, mask 255.255.255.252. And at the same time, I'll advertise the loopback while I'm here. And I'll also advertise this Ethernet interface through BGP. That's the /24 network. Once again, do show IP route to confirm what the networks are so that you can configure them properly in BGP. So section BGP, that's the configuration of router 4. It's been configured in autonomous system 4. Network commands have been enabled, and a neighbor relationship has been set up to router 2. Show IP BGP summary. Neighbor relationship is idle at the moment. Let's confirm that we can ping the neighbor 4.1.3.1. At the moment we can't. So it looks like there is an IP addressing problem or a network problem. Show IP interface serial 2/1. Or rather show run interface serial 2/1. It's got the wrong IP address configured. So let's fix that. Interface serial 2/1, IP address 4.1.3.1. That should be a /30 mask. And let's confirm that I haven't made the same mistake. Serial 2/0. Wrong IP address. So interface serial 2/0, IP address 4.1.3.2. I'll confirm the IP addressing of all the other interfaces before I continue recording. But hopefully now we should be able to ping that neighbor. We can, and show IP BGP summary. Neighbor relationship has gone active, so that's better. Show TCP summary as an example, or brief. No TCP sessions are up. Show TCP brief on this side. Notice the router has 2 BGP sessions up. Notice the port number 179. That's the port number for BGP. So the local router has initiated a session to router 3. show the IP addresses here. So router 2 has a session to router 3, and it has also initiated a session to router 1. BGP relationship has come up now, so if we do that command again, show TCP brief, notice router 4 with this IP address initiated a session to the local router using BGP, port 179. BGP uses TCP port 179 in the same way that Telnet uses TCP port 23. So show TCP brief now, we can see that the local router initiated a BGP session to router 2, and show IP BGP shows us that we've learnt about various networks through BGP, and hopefully we can ping the loopback of router 1, which we can. So this router learnt about this network through BGP from router 2, which in turn learnt about it from router 1 through BGP.